Welcome to lecture number 5 of FACS and HVDC transfer system. In this lecture, we solve some examples based on the previous theories. So the first example is a transformer secondary main voltage to a three-phase bridge rectifier is 345 kV. Calculate the DC voltage output when alpha is equal to 0 degree, 15 degree and 30 degree. So in this example, the line voltage, it is denoted by EL. It is given, it is 345 kV. It is given to you, right? So from this, you can first of all calculate the value of VDO. So VDO is equal to, you know that the equation 3 root 2 upon pi ELL. So when you put the value of ELL, so your equation become 3 root 2 upon pi into ELL. It is a 345 kV. So the value of VDO is 466 kV. So from that you can first of all calculate the VDO. Now as the delay angle is given, right? So your equation is become VD is equal to VDO cos alpha. So in first case, when the alpha is equal to 0 degree, so your DC voltage VD is equal to VDO cos alpha. Now you know that what is the value of VDO? It is 466 multiplied by cos 0. So what is the value of cos 0? It is 1. So your DC voltage at 0 degree delay, it is again VD is equal to 466 kV. Now in second case, when the alpha is equal to 15 degree. So your equation become VD is equal to VDO cos alpha is equal to 466 multiplied by cos 15 degree. So now what is the value of cos 15? It is 0.965. So 466 multiplied by 0.965, it is 466 multiplied by 0.965. So your value is 449.69 volt. 449.65 or 69 kilowatt. Now the third case, when the value of your alpha is 30 degree. So in third case, alpha equal to 30 degree. So your voltage in VD is equal to VDO cos alpha is equal to 466 multiplied by cos 30, and the cos 30, the value of cos 30 is 0.866. So your no load DC output voltage, it is 403.556 kV. Second example, an HVDC bipolar link using the 6-pulse converter is supplying the power of 500 megawatt at plus or minus 100 kV. The rectifier station is working at a delay angle alpha equal to 15 degree. Estimate the following. The first one is a no load DC voltage. Second one is the AC voltage on the converter side of the transformer. Third is the transformer secondary rating. Fourth is peak inverse voltage. Fifth is peak to peak ripple. And last one is the current on the secondary side of the converter transformer. So in this example, The power is given, it is a 500 megawatt. And the voltage, the DC voltage, it is plus or minus 100 kV. Now whenever the plus or minus sign is there, that means it is a bipolar link. So it is equivalent to the 200 kV. Remember this thing, this is a very important thing. Whenever the plus or minus sign is there, you have to consider the bipolar link. So it is minus 100 to 200 plus 100. So it is a total 200 kV, the your DC voltage is there. So you have to find the first one is a no load DC voltage, means VDO. So as you know that here also the alpha is given 15 degree, right? So as you know that the equation is DC voltage output is equal to VD is equal to VDO cos alpha. So here the VD is given, it is 200 kV, alpha is given 15 degree. So you can find the no load DC voltage VDO is equal to VD upon cos alpha. Now what is VD? It is 200. What is alpha? It is cos 15. So you will get the no load DC voltage, it is 207 kV. Now the AC voltage is the converter side of the transformer. Second part. So AC voltage of the converter side of the transformer, it is calculated by equation ESL is equal to VDO by 1.35. This equation we already derived in the third lecture. Okay. So the VDO, it is a 207 divided by 1.35. So you will get the AC voltage on the converter side of the transformer is 153.4 kV. Next is AC current on the secondary side. So the third part is AC current on the secondary side. So you know that the equation of the AC current on the secondary side, IS is equal to under root of 2 by 3 ID. Now here the ID is unknown, but here you know the equation PD is equal to VD ID. So you know the power, it is already given in your data, it is 500 megawatt, and the voltage VD, it is up to 200 kV. Right? So you will get the value of ID is equal to PD upon VD. So your power is 500 megawatt. So 500 into 10 raised to 6 divided by 200 kV. It is 2 into 10 raised to 3. So you will get the value of ID is equal to 2500 ampere. So when we put the value of ID in the above equation, so your IS is equal to 2 by 3 ID is equal to under root of 2 by 3 multiplied by 2500. So it is equal to 2040 ampere, means 2040 ampere. So this is your AC current on the secondary side. Now from that you can calculate the value of transformer secondary rating. So it is T is equal to, you know the equation, 1.047 into PD into 10 raised to minus 3. So is equal to 1.047 PD, it is a 500 megawatt into 10 raised to minus 3. So it is around 523.5 kVA transformer secondary rating. Now the peak inverse voltage. It is also known as PIV. So the PIV equation is PIV is equal to 1.047 VDO. Now what is a VDO? It is a no load DC voltage and the value of VDO is 207 kV. So the peak inverse voltage, it is 216.73 kV. So this is your PIV. Now the last parameter for your example is peak to peak ripple. You have to calculate the value of peak to peak ripple. So peak to peak ripple, it is called the PPR, is equal to 0.1403 VDO. So is equal to 0.1403 multiplied by 207. So your peak to peak ripple for this example is 29 kV. Now the third example, it is similar to the previous one. So for your practice, you can solve by yourself. Thank you.